I'm going to share the chapter 5 slides now. Can you see my chapter 5 slide on intermolecular forces? All right. I am going to start from intermolecular forces where I finished last class period. There are 3 types of intermolecular forces: hydrogen bonding, dipole-dipole interactions, and London dispersion forces. These are the intermolecular forces that act between particles and create 3 states of matter depending on the strength of intermolecular forces. Intra versus inter. Can you hear me?
Yes, I can hear you.
All right. We talked about intermolecular forces last time. I am going to go over the problems. We talked about 3 intermolecular forces: hydrogen bonding, which is the strongest, and then dipole-dipole attractions, and London dispersion forces. These are the 3. When you look at them, the strength-wise, hydrogen bonding is between 2 and 10. London dipole-dipole attraction are the next strongest, between 1 and 6. That the lowest, the weakest is the London dispersion force. If you compare these 3 to light bulbs, this is a strong light bulb. You can consider strong light bulb means the strongest attraction. Then this is less brighter. This is weaker. When they are present in molecules, this one is the more strong. When they are there, normally other 2 are not. When hydrogen bonding is the intermolecular force between 2 particles, the brightness or the strong strength of the hydrogen bonding overshadows, overbrightens. These 2 are not seen. When hydrogen bond is not there, when this is not there, when London dipole-dipole attraction are there, you don't see this one because the stronger force of dipole overshadows the last one. This third one, London dispersion forces, are present in all molecules and atoms in all compounds. Therefore, when this is the only one, London dispersion, it can be seen when first two are not present only. Therefore, London dispersion force is the weakest one that could be seen in all kind of intermolecular forces when hydrogen bonding and London dispersion are not there. I'm going to explain this a little bit more. London dispersion is weak. It's created by interaction between two non-polar molecules by fluctuating positive charges. This is a temporary positive and negative charges. Temporary. It's an instantaneous polarization of electron count of two atoms or any ions or between two particles. It's very weak. London dispersion forces are overshadowed when other two are present. Therefore, this could be only seen when there's no other force, intermolecular force, except London dispersion. Dipole is the attraction is the next stronger after hydrogen bonding. London dispersion force exists between atoms and molecules. They are mainly polar molecules. This is London dispersion, non-polar. Their strength is weaker. There, however, as the number of electrons in particles or atoms and molecules increases, they also increase. It can add up to in large molecules, there are more electrons. They can add up. Also, depending on the surface area, I'm going to talk about surface area. London dispersion force could add up and give significant and work as a significant force. Dipole-dipole attraction is found among the polar molecules. When dipole-dipole interaction are present, London dispersion, even though it's there, it's not seen. Dipole attractions are present in acetone. This is butane. Butane has no polarity. Therefore, it's London dispersion only. When London dispersion is the only force, normally the boiling point is lower. When the dipole-dipole attraction, which is stronger, boiling point is higher. Acetone has we talked about it, it's a dipole going in this direction. Therefore, acetone is a liquid. Nail polish is acetone. Butane is a non-polar molecule. Therefore, only force is London dispersion force. Acetone is a polar molecule. Intermolecular force is dipole. The hydrogen bonding, is the strongest attraction between strongest dipoles, which are, this is the strongest dipole. These three dipoles, electronegativity is the highest here. Therefore, this is the strongest. Then the next electronegativity is oxygen and nitrogen. However, all these three dipoles are stronger than any other dipole. When these dipoles are present in molecules, they strongly attract each other, particles containing these strong dipoles. Therefore, it overshadows London dispersion as well as any other dipole-dipole attractions. Water molecule has polar oxygen, hydrogen-oxygen bond. This is the hydrogen bond between one pole of one molecule with the opposite pole of the other molecule. The attraction between these dipoles through their oppositely charged ends of the dipole is called hydrogen bonding. This applies to any dipole-dipole attraction. This is hydrogen bonding when OH, NH, and FH are the dipoles. Hydrogen is largest intermolecular force. It's between 2 to 10. I talked about it. Is the brightest or the strongest. When this is present, it's kind of a, compared to other two, this is the prominent one. Therefore, other two are overshadowed. For water, it is about 5 kilocalories per mole. If you compare intramolecular force, intra means within water molecules. That's the covalent bond. Is much higher. As a rule, intermolecular forces are not intramolecular forces. The hydrogen bonding is intermolecular between two water molecules. The ionic compound, I shown it before, has ionic attractions. They are intraparticle. It's not inter. Therefore, they are the strongest. Hydrogen bonding in liquid water has important effect on physical properties of water, even though they are smaller than intramolecular covalent bonds. They have important. Hydrogen bonding between water molecules create higher boiling point for water as well as high heat capacity. Specific heat of water is the highest because of hydrogen bonding, attraction between their neighbors. Hydrogen bonding are not only OH, NH, FH groups, dipoles, also considered hydrogen bonding. We talked about it. For example, in DNA, where you find a double helix of nucleic acid, those two double helix, two strands are held together by NH bond between base pairs in the helix, each helix. Now let's talk about this. The liquid state disruptive forces are. Disruptive forces are kinetic energy. Cohesive forces are intermolecular forces. In liquid state, they are both similar. Therefore, roughly the same. In solid, cohesive forces are weak compared to disruptive forces. This is the correct answer for liquid. In solid, liquid, in gases, the disruptive forces are the highest, and the cohesive forces are not there. Therefore, in liquids, the statement A is the correct answer. We are talking about intermolecular forces and kinetic energy. Kinetic energy is considered disruptive. Intermolecular forces are either one of them, hydrogen bonding or London dispersion or dipole-dipole interactions are called cohesive forces. In a molecular system, that's a statement. That's true. Kinetic energy is destructive. The potential energy which is the attractive force between two particles of a matter, is electrostatic. Positive charge and magnetic electrostatic attraction. Therefore, it is true. The macroscopic properties of the liquid state include, this is the state of matter question. Liquid state has a definite shape and definite volume. That's not true. Definite shape and definite volume is solid. Molecular theory and physical state. Which of the following description apply to matter in gaseous state? Following description. We talked about gaseous force state. Cohesive forces are weaker than the disruptive forces. Therefore, there's no cohesive forces in gaseous state. That creates gaseous state, definite volume, that is solid. Disruptive and are equal. That's in the liquid state. Pressure changes significant influence because the particles are in the gaseous state. Particles are far apart. Changes in volume influence the pressure changes. That's the correct answer. C is the correct answer. Which of the following description applied to matter in the solid state? Definite shape, high density. This is correct. Let's look at the other. Cohesive forces dominate over the disruptive. That's correct. Kinetic energy dominates over the potential energy. That's not correct. Therefore, there are more than two correct answers. D is the more than two choice with more than two correct answers. For the state with indefinite shape, what is true? Indefinite shape is liquid state or gaseous state. Both gaseous and liquid state. That's the correct answer. Solid state has a definite shape, not indefinite. Therefore, D is the correct answer. The state with the definite volume. What is definite volume? Solid and liquid. Solid state only. That's the correct answer. C. The state where cohesive forces dominate over disruptive forces. Normally, gases have more kinetic energy, more disruptive forces. Therefore, gases is not the answer. Both solid state, liquid state, and solid state cohesive forces dominate our disruptive forces. Therefore, both liquid and for sure, cohesive forces are equal in liquid state. Therefore, that answer is compared to liquid. Solid state dominate. I didn't look at the fact that they are greater, but dominate means solid state. Answer is B. For the state where potential energy dominates over kinetic energy, Potential energy is the intermolecular forces. Dominates over kinetic energy. Potential energy is same as cohesive energy. Kinetic energy is disruptive. That's the same question, almost. The answer is B. For the state where particles are relatively close each other, for the state, either it could be solid and liquid. So which one is relatively close together? It could be both liquid and solid, but solid state only could be the answer. This is over here dominate, over here relatively. Therefore, the answer become both. I didn't look at the relatively close together. Relatively close compared to gaseous state. Both. Therefore, answer is C. The phrases particles close together and held in fixed position. Completely fill the container. Which state this applies? Particles are close together. That's solid. Completely fill the container. That's gas. Therefore, both solid and gas should be the two answers, two choices. Solid and gas is B. Therefore, answer is B. Do you guys have a question?
No, sir.
All right. I'm going to continue the questions of intermolecular forces. Intermolecular forces differ from intramolecular. Inter means between. In a particle, forces are within, it's called intra. Water molecules, two water molecules between is intermolecular. Intramolecular is OH bonds in the water molecules. Intermolecular differ from intermolecular is weaker. They are much stronger. This is not true. Intermolecular forces, they appear only in none of these are correct. Intermolecular forces, both liquid can have both. Liquid is a particle as well as bonds. This is not true either. They are not strong. Intermolecular force is weak. Therefore, that's not true. Therefore, none of these. That's kind of a negative answer. In which of the following pairs of molecules would the first listed number of the pair have higher boiling point than the second pair? Now let's look at this. You have to look at the polarity. This is more polar. HF bond is more polar than HBr. Electronegative differences are greater for HF. We need to the following pair have higher boiling point. This is correct. This is London dispersion. This has more electrons. Therefore, chlorine have a higher boiling point. This is non-polar. This is polar. There's an electronegativity difference is there between nitrogen and oxygen. Therefore, this is the high boiling. Therefore, these are not correct answers. Therefore, correct answer is A. Which of the following is the strongest intermolecular interaction? You are asking intermolecular. This is intramolecular. Covalent bonding is within a molecule. That's like a water molecule, has OH bonds. They are not they are intramolecular. Dipole, London dispersion, hydrogen bondings are the three intermolecular forces present in molecules. Stronger interaction is hydrogen bonding. D is the correct answer. Which of the following is usually the weakest intermolecular interaction in small molecules? Small molecules have less electrons. Therefore, London dispersion force become the weakest attraction. When the molecule become bigger, London dispersion can increase. That's why we started weakest in smaller molecules. Therefore, answer is C. Hydrogen bonding is the strongest. Which of the following influence the strength of a London dispersion force? Number of electrons in the molecule. Yes, that's correct. Size of the molecule. That's correct. Size also increase electrons. Shape of the molecules. That's true. If you have a shape of the molecule spherical and flat molecule like this, the flat molecules or linear molecules have larger surface area. Therefore, attraction between are lower because surface area is so. Attraction between flat surfaces. We're going to look at linear hydrocarbons. They have surface area, large surface area. Therefore, they have higher London dispersion, attraction from London dispersion. All these three are affecting the London dispersion force. We're going to look into this. Which of the following molecule has lower boiling point? Low, I couldn't see. That's why I went back. Lower. This is a non-polar molecule. Therefore, London dispersion, LD. This is a OH group, hydrogen bonding. This is a dipole, oxygen. Oxygen, this is dipole. Dipole, dipole. Therefore, this is the lowest boiling point, is the lowest intermolecular. This is the correct answer. That's also a dipole. Answer is A. Similar question, highest boiling point is the one with the hydrogen bonding. When the highest boiling point has the highest dipole, that's the hydrogen bonding OH. That's at the highest boiling point. Answer is B. When octane, which is a non-polar molecule, what kind of forces had to overcome? Non-polar has London dispersion. That's not true. Hydrogen bonding is not true. Dipole, dipole, they are not there. D is the correct answer. Which molecules exhibit London dispersion force? That's an ionic compound. Ionic compounds are like covalent compounds. They have higher ionic bond strength. They are not intermolecular forces. This is a non-polar molecule. That's London dispersion. Ammonia ion is polar. Therefore, an hydrogen bonding. NH dipole. HBr is polar. Dipole, dipole. London dispersion force is the weakest. It's exhibited by methane molecule. Answer is B. I will correct that. Answer is B. London dispersion forces is present in. The question was not weakest force. London, we talked about this. London dispersion force is found in all interaction. When the interactions are not, other interactions are not present, is exhibited. Therefore, This is ionic compound. These are all molecular compounds, non-polar, polar. They all have London dispersion. But I was interpreting which one is the London dispersion. That's this, definitely, because there are no other interactions. These are other interactions. When there are other interactions are there, like hydrogen bonding, like London dispersion force. This is not exhibited. It's not showing up. It's overshadowed. Therefore, answer is E. Which molecule exhibit hydrogen bonding? This is, hydrogen bonding is NH, OH, FH, dipoles. Has to be there. Therefore, this one has NH. None of the others have NH or one of these three. Therefore, C is the correct answer. This is about liquid state. I couldn't see this in my slides. We are moving on to liquid state. We're going to talk about how liquid state is created from gaseous state. As the pressure of a real gas increases, molecules become closer. Therefore, they can get attracted through intermolecular forces, either hydrogen, London dipole, or London dispersion force. When distance decrease from the pressure or the temperature pressure increase or temperature decrease, this attraction can take place. The distance decrease, molecules touch each other as the distance decrease due to high pressure or lower temperature. Liquid has little space. We already talked about liquid space have little space with the molecule. They become gases compress to liquids as the space within molecule decrease. The density is much higher than the gaseous state. Liquid has higher density because in a gas, molecules are in a larger volume. In a liquid, it's condensed. The position of molecule in liquid is random. They can roll over. They can slide over each other. Therefore, liquid becomes fluid. They can flow. Therefore, they can show resistance to flow, viscosity. They could have different properties depending on the intermolecular forces. Higher the attraction, less flow it shows, viscous liquid. One of the properties of liquids are surface tension. Surface tension is a phenomenon that we see on the surface of a liquid. It's because uneven distribution of attraction in a surface of a liquid. If you look at a surface, a molecule in the surface are attracted to other molecules through intermolecular forces. But on the top of the surface, right here, there's an imbalance. There's a preferential pull. So therefore, there's a preferential pull towards it. Therefore, the surface kind of has a force. And in a liquid, in a capillary tube, liquid surface become. Because between liquid and gas, interaction is higher. Therefore, this pull down to the hemisphere between water and glass is this way, going to the bottom. That's because of the surface tension. It creates a skin-like layer, elastic layer on the surface. It relates to intermolecular attraction between molecules. In mercury, mercury is a liquid. This is other way around. In water, glass, this is this way. Because the water and a glass has higher attraction. Therefore, this is higher attraction. In here, water, glass, and mercury, this is mercury. Attraction between glass and mercury is weaker than mercury attraction. Therefore, mercury pulls up. That has a meniscus on the opposite way. Now let's look at the surface tension more. This is what I am talking about. This is the surface of a liquid. If you look at that surface, inside the liquid, a particle or molecule, water molecule, is attracted equally. On the surface, it is imbalanced. Therefore, this pulls down. Therefore, this becomes pulled into water inside. Therefore, this creates a surface tension on the surface. Now we look into liquids and what is the evaporation of a liquid. Evaporation is liquid going to a gas. Condensation is the opposite. Liquids evaporate if the temperature is higher, evaporation becomes higher. Temperature means kinetic energy. That allows liquid particles to operate, escape out of liquid state to gaseous state. High the kinetic energy, more rapidly the low means slow evaporation, rapid evaporation. If a molecule at the surface signaling has moving slowly, it cannot escape. To escape water in a beaker, water molecule to escape, it has to have high kinetic energy. It's kind of a diving out of the liquid. However, it's moving rapidly. Kinetic energy is higher. They can make it escape, enter the gaseous space in the top of the beaker, right here. Now, evaporation and condensation are related to vapor pressure and boiling point. We're talking about boiling point is when the liquid goes to a gaseous state. Vapor pressure is the pressure on top of the water solution, liquid solution, gaseous pressure. Higher the temperature, higher the vapor pressure because kinetic energy. So we're going to look into this. If the container is open, the particles of the liquid will escape, continue to escape until if the open container, it can evaporate slowly and all the liquid would be completely gone from the container. Container is closed. Then at a particular temperature, there's an equilibrium. This one is closed. Equilibrium wave pressure, depending on the temperature, is established. Higher the temperature, higher the vapor pressure on top of the solution. This equilibrium is in a closed system. Open system is one way, all the liquid is converted to gas. So there's an equilibrium here in a closed system. Number of water molecules escape into the top of the water solution, and number of molecules coming back into the liquid is same. Rate of same is opposite rate, same means equilibrium. Equilibrium is expressed this way. Double arrow. Liquid to gas. The rates are same. The partial pressure of the water, of any liquid, is called the wave pressure. We talk about Dalton's partial pressure. There could be other particles in the gaseous phase, gas phase. We only looking at the pressure exerted by liquid, that liquid only. So therefore, partial pressure increase with temperature. Therefore, it is a function of temperature. vapor pressure increase with the temperature until it equal to the atmospheric pressure. When this is very important, relating to the boiling point. When the temperature increase, when the liquid become boiling point, partial pressure on the top is equal to the atmosphere, atmospheric pressure. That point, boiling, the temperature at which vapor pressure over top of the solution is equal to atmospheric pressure, whatever the pressure in the atmosphere. That temperature is called boiling point. Therefore, defining boiling point is very important. Boiling point of a liquid is defined as a temperature at which vapor pressure of a liquid is equal to the atmospheric pressure. This is important. You heard about this. Water boils at lower temperature, at high elevation, lower temperature. Baking cake in a high elevation requires more time on baking. The baking instructions for recipes are different depending on the elevation. Let's consider evaporation in an open container where all the liquids will go into the atmosphere. Evaporation. Can you see here? This is the atmosphere. These are the nitrogen, oxygen. These are the liquid particles. So when the at a certain temperature, they evaporate at a certain rate. They escape to gaseous phase. This is the partial pressure is pressure from the gaseous liquid particles of the gas, liquid in the gaseous converted to, that's a red balls. That's why we have to use partial pressure, because it's a gaseous mixture if it is open to atmosphere. Now let's look at the changes of vapor pressure with the temperature. Different liquids have different pressure temperature relationship. If you look at here, chloroform, which has the lowest intermolecular force because it's dipole, ethanol have hydrogen bonding. This is dipole-dipole interaction. This is hydrogen bonding. Water is have much higher hydrogen bonding. Acetic acid, they have polar, much highest hydrogen bonding because it has dipoles and hydrogen bonds together in the acetic acid. It has the highest boiling point. Boiling point, the vapor pressure on the top of the solution increase as the temperature is increased this way. Vapor pressure is increased as the temperature for acetic acid going like this. At the point when the atmospheric pressure is normally 760 torr, this start to boil. Therefore, from this point, everything start to change to a gaseous state. That's the boiling point. boiling point of a liquid is defined as temperature at 760 atmosphere, temperature at which liquid boils. For acetic acid, that's 170. For water, it is 100. Alcohol is 78. Chloroform has the lowest intermolecular force. It has the 61.7. So definition of a boiling point is, we go now. If you look at trends in boiling point, if you look at chloroform, which has the dipole attractions, molecular weight is important for intermolecular forces. When you are comparing two types of substances, their boiling point, we have to consider their molecular weight, because molecular weight is related to London dispersion force. If you have larger, heavier molecule which has London dispersion, that can complicate the hydrogen bonding or the dipole attraction. Hydrogen bonding here, hydrogen bonding here. Water has two dipoles. Therefore, at the highest boiling point. Next highest. This has the largest because this has hydrogen bonding plus dipole as well as that. Acetic acid. This got hydrogen bonding here, dipole. Therefore, which is much higher. Therefore, when you're considering molecular weights and intermolecular forces, it can explain the trends in boiling points. The effect of intermolecular forces on London dispersion, boiling points. Effect of intermolecular forces on boiling points. If you compare two substances, methane, natural gas here, water here, you have to compare comparable masses because of the London dispersion force could affect if you have high molecular weight, complicate things. Therefore, when you are comparing boiling points or intermolecular forces, you have to look at the similar weights. 16 and 18 are very close to each other. Therefore, these two, methane has lower boiling point than the water because of the hydrogen bonding. This one has London dispersion, methane, weaker. Therefore, methane has the lower boiling point. Hydrogen bonding between water molecules, it has higher. When you consider these two molecules, this is much higher molecular weight. Both are non-polar. Therefore, you can see when the London dispersion force is present, higher greater the molecular weight, higher the boiling point. Molecular weight is hexane, 6 carbon atom, hydrocarbon. For ethane, methane, which is 1 carbon. This has low boiling point. You can explain. When a molecule is this shape, however, shape doesn't matter here. There are more electrons here, less electrons here. Total number of electrons in methane, 6 plus 10 electrons. 6 from the car, 12, 6. 6 plus 4 is 10. This got 6 times 6, 36, plus 14. 50 electrons. Therefore, larger the number of electrons or the molecular weight is larger, means more London dispersion. Let's look at the comparable molecule with different shapes. These are both hexanes. Formula is same. H12. There are 3 times 4. C6. H12. This is both have same molecular formula, C6H12. There's a same formula. Molecule is spherical here. Therefore, it has less surface area. This has flat shape. Is flat molecule. It has larger surface area. Surface area is larger. Therefore, this got more same formula. This has larger, this has smaller. 36 versus 9.3 Celsius. That's how they both have the same number of electrons, but the molecular shape is different. Dimethyl propane, 2,2-dimethyl propane is this compound. These two are called isomers. Same molecular formula, different arrangement of atoms in these two compounds. These isomers have different surface area, therefore different boiling points. London dispersion force is the intermolecular force. I am going to talk about phase changes. or changes associated with temperature in next class period. And solid state. And we're going to look into phase diagrams. You guys are still here? Are you there? I am going to finish the class. I will see you on next Monday.
Yes, sir.
All right. Take care.
We don't meet Wednesday?
I'm sorry, Wednesday, I was skipping a day.
Okay.
We meet on Wednesday. All right.
Okay.